See, to understand the type of static friction and the sliding frictions, we have one lab activity. In lesson 1, we have one lab activity, that is to understand the concept of limiting force. Now, in lesson 2, we have one more lab activity, that is understanding the nature of friction. To understand the nature of the friction and the concept of static friction. We have the 4 types of frictions. So, that is static, sliding, and one more is rolling, and the last one is fluid friction. So first, to understand the concept of static friction and at the same time the nature of friction, we have this activity, lab activity. So what is the aim? Here I wrote it. Now, to do this lab activity, what are the materials required? What are the materials required? Here you see this diagram. To understand the concept of the frictional force, first you require a big table, one table, and this is the string. This string should be an inextinguishable string. Means that the string should not be stretchable. Some, when you add the weight, the strings are stretched, so that such type of strings we should not take. The string whatever you are taking, that it should be inextinguishable string, you must take it. Next, this is a toy trolley. Toy trolley. And here on that I kept one small wooden piece. Small wooden, not piece, block. Wooden block. Just you place. Here we are discussing about what are the materials required. So here the table, this is string, this is known as pulley, and here the weights, hook, and this is the toy trolley, and this one is the wooden block. So these are the materials required to do this lab activity. Now coming to the procedure. First you take the table. On the table you take the toy trolley like this, and it has weights, and place it at one end of the table. On that trolley, you must take one wooden block and place it on the surface, means on the trolley, on the surface of the trolley. Next, you take one inextinguishable string, and one end of that string you must tie to this trolley, and the another end you must pass it over the pulley, and the another end you must tie with the weight hanger. You must tie with the weight hanger. So when the arrangements are over or connected, then you take the weights, either 50 grams, according to, not 50 grams, just you take little amount of weights and add to this weight hanger. When you add the weight hanger, when you add the weights to that weight hanger, then what happens? Because of that weight, this this mass of these weights are pulling the string. When they're pulling the string is tied to toy trolley. So obviously the toy also start moving. The toy also, or toy trolley also start moving, means it has an acceleration. Initially the toy is at rest. When you are adding weights, the toy starts moving, means there is a change in the velocity. So it has an acceleration. When it has an acceleration, then you observe the motion of the trolley and the wooden block. Next, you add one more weight. One more weight you add to the weight hanger. Again you observe. When you are adding weights one by one, what happens? The speed or the acceleration of the toy trolley increases. When the acceleration of the toy trolley increases with the same speed, the wooden block which is on the surface of the toy trolley is also moving. But here we have to understand the relative motion. We have to understand the relative motion. Relative motion means what? With respect to the surface of the trolley, the block is at rest. The block is at rest. But with respect to the surface of the table, when you are adding weights, the trolley is moving. Along with the trolley, the block is also moving. One more example I will tell you. Suppose when you are standing under near a tree and a bus is moving. When you observe a bus, with respect to you, the bus is moving. Along with the bus, the persons which are in the bus also moving. But with respect to the person which is in the bus, when he observes, the bus is moving, but the person which are in the bus is not moving. So whether an object is rest or in motion, it depends on the point of observation. It depends on the point of observation. See here, with respect to the surface of this table, toy trolley is moving, and along with that wooden piece also, wooden block also moving. But with respect to the surface of this toy trolley, what happens? This trolley is moving, but the wooden block is not moving. Now keep on adding weights. When you are adding weights, the acceleration increases. When the acceleration increases, what happens? The surface of this toy trolley exert a force on the wooden block. Exert a force on the wooden block. At the same time, the wooden block also exerts some force on the surface of this trolley. When you are adding weights, the toy trolley starts moving. Along which direction it moves? Along the left hand direction. Left side, the trolley starts moving. When it is moving or accelerating at one particular weight, when you are adding that weights, what happens? The surface of this trolley exerts a force on the wooden block. At the same time, the wooden block also exerts a force on the surface of this trolley. So these two are in the opposite direction. Suppose if the trolley is trying to move along the left hand direction, the wooden block is trying to move along the right hand direction. The wooden block is trying to move in the right hand direction. So up to certain weight, certain mass, along with the trolley, the wooden block is also moving. But when you add one more weight to this, after certain level, when you add weight to this weight hanger, what happens? The trolley starts move left side and the wooden block starts move right side. Means the wooden block is moving. The wooden block is moving. Means initially these two are in the rest position. These two are in the rest position. But after some weight, the wooden block starts motion. The wooden block starts motion means it is sliding from the surface of the trolley. So in these two examples, in this is not example, situations, it has two types of frictions. The wooden block has two types of friction. Up to certain weight, the wooden block is at rest, means it has static friction. What is static friction? Static friction is the friction which comes into play when the surfaces of the objects are at rest relative to the objects or relative to each other. Means these two are at rest relative to each other. Such a type of force we'll call it as static friction. But this static friction has a limit. That static friction has a limit. After that, it comes into motion. I means it is sliding. When the trolley starts moving towards left, the wooden block starts moving right, means it is sliding. Means at that condition it has a sliding friction. So what is sliding friction? Means sliding friction is the friction which comes into play when the surface of the two objects are in contact with each other. Okay, so this is the procedure part. See, from this lab activity, we observe that there are two types of frictional forces are acting. One is the static friction, the other one is sliding friction. Here, with respect to the surface of the table and the surface of the trolley, there exists a see, a little I said wrong. Here, when compared to the surface of this table and the trolley is moving and the surface is at rest, means when the objects are in contact relative to the surface, then if one object moves, at that condition it has a sliding friction. It has a sliding friction. Now coming to, with respect to the surface of this trolley and wooden block, these two are at rest only. See, with respect to the surface of this trolley, the wooden block is at rest, means at that condition it has a static friction. So, through this lab activity, we can understand easily the types of two frictional forces, static friction and sliding friction. Thank you.